Okay, if you have gone through part 1 video, then you will understand even better. Now let's see terminologies in function, that is function, prototype or declaration. So we are quite familiar with declaring a variable. How do we declare a variable? Int, that is the data type with the variable name and semicolon. So this is declaration is required to convey to the compiler that so and so variable is used in this program and allocate some memory to it. The same happens with function. So before defining it, say from main method you are typing or writing the program. So here when the compiler is compiling each statement, when it encounters this, so as we know that this statement is being replaced with that function, so this is not required, so please ignore this. So when this statement is encountered, the compiler will throw an error saying that add is a undefined variable or whatever, right? So hence before definition, if there is a function call, that is before defining the function, as we have this defined it what the task of the function is, before that the function call appears, then there will be an error. To avoid or to get rid of this error, you need to include a function prototype statement or a declaration statement. What is it? It's nothing but the header. The header is the first line of the function definition. So this is called as function. See, these terminologies are very important. Then only you can understand, because they are interlinked. See, when I'm speaking about prototype, I have to speak about header also and definition also. So this is function header, this is function body. Both together is called as function definition. Function definition. Okay, that is you're defining the task of that function. So the prototype is nothing but you can simply write this exactly with semicolon. Int add int. You can just write the data types also, or if you're getting confused, you can just write int a, int b along with semicolon. So this becomes the function declaration or prototype statement. So why are we using this? This is to convey to the compiler that the add function is defined and used in this program. Okay. Coming to function call. So next terminology is function call. Function call is the statement, that is this statement is the function call where you are passing the control of execution to the function definition. So this is function call. Okay. Next, coming to function definition, which function definition is nothing but function header and body together. That's what we have already seen. Function header with the function body together is function definition. So I hope you have understood the terminologies. Now let's see the syntax. I usually go the reverse way because usually you forget. So the syntax of the function is this way. So here, while I was writing the program, this function, you understood why I had used each of these statement, right? So if I first tell you syntax and go here, you get confused. So that's why I go with the reverse way. So build the code first and then see why it is used. Syntax. So syntax is the return type. Okay. And then comes the function name. Function name is nothing but the identifier. So the rules applicable for identifiers is applicable for this because it is an identifier. And you can have arguments with data type, argument 1. So like that, data type argument 2 and so on. You can have any number of arguments in function header. Next, you have the function body, and you can have the return statement at the end. Now, when should a function have a return statement? A function has a return statement when a function is returning something back to the calling function. It's not compulsory that you should have a return statement in a function. It all depends, and it's usually the programmer is comfortable in returning a value to the calling function. But it is a very simple program, then it need not return anything to the calling function. Otherwise, most of the cases a function returns a value. Otherwise, say suppose that there is no return statement, there is nothing to return back, say some display functions or some print function, it has to simply print something, right? Just a value is passed, or a variable value is passed to a function, the function will print that value. In that case, it need not return anything to the calling function. So that time there is no return statement. When there is no return statement, then what is the return type? Then the function return type will be void. As it is not returning anything, it becomes void. Whereas in this particular example, a return statement is returning a value, hence the return type is int, which is the type of the variable that you are returning. Now we'll see a return statement can return a variable, or it can return a constant, or it can return a expression, an expression. Okay, saying returning a variable, we have seen in this example, you are returning a sum variable which is declared and used here, right? Coming to constant, for returning a constant, we have seen in main function. So return 0 is being returned. If it is, so that's why 0 is an integer, so return type of int is return type of main is int. If you have 0.0, then it would be float. So usually we return 0 for main. Whereas in coming to a function, you can have return 1, 2, 3 like that. Or if it is a character, return y, return n, like that also you can have. So that's with respect to constant. Next, returning an expression. So an expression can be written. For this, I have an example. So the same method, the function I have rewritten here. So here we see it's returning. The same function can also be returned in this way. Please observe, the function here will accept 2 inputs, create a sum variable, add those 2 inputs and return it back. The same thing can be done with one single statement. That is, you need not create the sum variable. The 2 inputs are stored in x and y. You simply add the returning. That is, here we are seeing you are returning an expression. Expression, when it encounters in the execution, it will evaluate that expression. So this x plus y, whatever value is being passed or stored in this x and y, that is being added and returned. So what is the resultant value of this expression? When you are adding 2 integers, obviously you get to the result as integer. So you return the integer. So return type is this. So now we have seen the return statement can return a variable, a constant, or an expression. So these 3 things are clear. So the same thing here you are returning. Now we'll see the function call for a function which is not having a return type. So here, why have we equated this function call to this variable? This is nothing but this previous example itself. Just I have changed the names result here instead of sum. And here the variables here are x and y. Here it is a and b. That is the formal actual parameters. Oh, I forgot to tell this. The variables or whatever you pass in the function call is called as actual parameters. Okay, and the one that you receive at the function, that is the formal parameters. Okay. So here I just wanted to show, in previous example I had used the same names and I had told that they are stored in different locations, and it need not be the same names also, it can be different names as well. So here AB is used and here XY is used, right? It need not be the same name is what I'm trying to say. Now let's see what's the actual parameters, what and all can be actual parameters. So in this case you saw it should be, means we have passed a variable. Actual parameters can be variables, constants, or it could be expression again. So you can have add, okay, let me write here, add a comma b is what you're passing, right? So this is 1. Next you can add 5 comma 6, that is for static addition. That is for dynamically what is stored in A and B. If you don't know and you know clearly what you have to add, you can directly pass like this. And again it depends on what type of function it is. So this might look for very simple for you, but this is just for an example for understanding. An expression, so you can have a plus plus or plus plus b like this also. So here the expression also can be passed. The evaluated value of this will be passed to the function. Now coming back, I was telling that when the function doesn't return anything, when the function is not returning any value, how the function call should be. So this type of function call we are familiarized with the previous example. Why did we equate this function call to this variable such that the returned value is stored here? When the function is not returning anything, then you need not equate the function call to any variable. In that case, the function call would be just the function name along with the arguments, that is the parameters, actual parameters, whatever you want to pass. Okay, and usually I've seen students making mistake of writing int a, int b. Not required. You not declare anything. You have already declared and used that variable, and that values you are trying to pass is what is you're trying to do. So this is about the terminologies on functions. So we have seen what is function prototype or declaration, then function call, function definition, then coming to formal parameters and actual parameters. Also the function which has the function call is called, that is the main to this add is calling function. Okay, and the called one, the add function is the called function. Okay, so these terminologies please keep in mind, and we have seen different variations in written statement, different variations in actual parameters. Okay, let's see now different variations in formal parameters. In formal parameters, definitely it should be a variable only. Why is this? Because here you are declaring the variables, because the value that is being passed to should be stored somewhere, and only a variable can hold a value. So here it can be variables or pointers. What is pointers we'll be seeing in the later videos. So as of now understand, so a variable only should be a formal parameters, that is a declaration. Along with data type you create the variables. So this is for formal parameters.